Hello. In this next session, so we'll be discussing about solution, solid solution, types of solid solution, and factors affecting solid solubility, or it is also called as Hume-Rotary rule. Now, in the previous part, we had discussed about alloy. Now, if alloy is to form, so as I told, it should be heated and it should be mixed together. So hence, we should know the concept of what is solid solution. So what is solid solution and types of solid solution and the factors that affect solid solubility. So if it is soluble in each other, so then only we can get an alloy. If one is soluble in another, example copper soluble in nickel, similarly nickel soluble in copper, then only I can get an alloy. Hence, it is necessary to know the concept of what is solid solution, types of solid solution, and factors affecting solid solubility. So that is what we will be discussing in this part. So coming to the first thing, solution. Now what is solution? It is already a very common word that everyone know, solution. So what is solution? How we can define solution? So according to definition, it says that it is a homogeneous mixture. It is a homogeneous mixture of, so very important word is homogeneous mixture of chemically distinct substances in which atoms or molecules of one substance uniformly and randomly dispersed throughout the other. That's how the definition says. It is a homogeneous mixture. So when two metals are mixed together, I should get a structure that should be uniform throughout. That should be uniform. That is called homogeneous mixture. 100% mixing of one in other. Example, if you take metal A and metal B, A should be 100% mixing in B. Similarly, B should 100% mixing in A. So then only I get a new homogeneous structure. Homogeneous, that is, it should have a atom distribution throughout uniform. That is called homogeneous. It is homogeneous mixture of chemically distinct substances. Same example, if you take copper has got different crystal structure, whereas nickel has got a different crystal structure. Chemically distinct, that is, chemical makeup and structure is totally different. That is what it says. Chemically distinct substances in which atoms or molecules, atoms of copper and atoms of nickel, or molecules of copper or molecules of nickel, so are uniformly and randomly distributed throughout the other. So when they mix together, uniform distribution you can have or random distribution can we have, but 100% that is distribution will take place. That is what it's called, that is solution. It is homogeneous mixture of chemically distinct, totally different chemical makeup of two metals, chemically distinct substances in which atoms or molecules of one substance are uniformly or randomly distributed in other. That is called as solution. Very simple example, if you take salt and water. If you add salt in water, it gets dissolved in water. We cannot separate it later on. That is what important in alloy. We cannot separate it. So if you add salt into water, it dissolves. So then we cannot separate salt and water once again. That is 100% uniformly distributed in other. Or alcohol and water. If you add water to alcohol, it gets dissolved in alcohol. So we cannot separate it. It will be a mixture of alcohol, water. So that is called as solution. So homogeneous mixture. So here same example, if you take salt. So salt in very less proportion is added into, that is, water. Similarly, other example, if you take water is added in less proportion into alcohol. So a higher proportion, those present in higher proportion is called as solvent, lower proportion is solute. So solute, if you take salt and water is called as, it will be solvent, whereas salt is solute. That is definition of solution. I don't want solution, I want solid solution. So what is solid solution then? So it is one mixture. It is solid solution is one in which atoms or molecules of one kind are distributed throughout the other, produce a mass. To produce a mass In solution it will be in liquid state. Solution it will be liquid state. Here, so what is solid solution? Solid solution is a mixture of atoms or molecules of one kind distributed in other. Throughout, so to produce a mass which is homogeneous. Once again, it should be homogeneous mixture. In solid condition, they both get distributed in each other to get a new metal or new alloy, that is called as solid solution. Example, copper, nickel or gold, silver. So both will be in solid state, they are mixed together. So it will be get a new alloy, a copper, nickel alloy or gold, silver alloy. So that is called as solid solution. So once we know solid solution, next types of solid solution. So here coming to this types of solid solutions, I can have two types. So first one is substitutional solid solution, second one is interstitial solid solution. So what is substitution, what is interstitial, already we have discussed in the previous sessions, that is where imperfections. In case of imperfections, we have discussed about substitutional and that is interstitial. Now the same concept is used in solid solution also. Substitutional solid solution. So substitutional solid solution is one where one atom gets substituted for the other. To the other. Example, nickel atom gets substituted for copper atom gets substituted for nickel. So that is called substituting. So one atom is substituting for the other. So that is called a substitutional solid solution. So here we can have two types, ordered type of substitutional solid solution and second one is disordered type of substitutional solid solution. So very simple, the definition or the name itself says ordered, second one is disordered. So what is ordered, what is disordered? Now ordered, so this is the structure, so these are the atoms. So ordered one is one where the atoms get substituted for the other and are uniformly arranged in a systematic manner. So if you take copper nickel, example if you take copper zinc or aluminum copper, so copper atoms you can see it is distributed in a uniform manner. So first line copper, second line then zinc, then copper, then zinc. So ordered form it gets distributed. So that's what definition says, randomly or uniformly distributed. If it is uniformly distributed, then it is called ordered substitutional solid solution. So in a uniform manner it is getting distributed. So other one is disordered, just opposite to that. So randomly here and there it gets substituted. One in the first row, then in the other in the third row, then fourth row, like that. Randomly they get that is substituted. That is called as disordered. So you can see the example here. So two atoms here, then one here. So randomly it does not go in ordered form. It does not substitute in an ordered form. So in a disordered form, randomly it gets substituted. But substitution takes place here also. So that is called as disordered type of substitutional solid solution, where atoms randomly get substituted over the entire structure. That is first type of, that is substitutional solid solution. Second one is interstitial solid solution. So what is interstitial solid solution? So we already know about interstitial space. It is a space between the atoms. When the atoms are arranged in a systematic manner, the space between the atoms, you can see this is a space, this is a space. So these are all the space between the atoms. That is called as interstitial space. Now when an atom of one occupies the interstitial space, then it is called as interstitial solid solution. Very simple example is, that is steel. Now steel, if we go on adding carbon into steel, we get different types of steel. So with a change in percentage of carbon, we can get steel. Now if carbon has to be induced into steel, so size of the atom of carbon will be less than the size of the atom of steel. So you can see this is the solute atom, that is carbon, this is a steel atom, solvent. So as I told, higher percentage will be solvent, lesser percentage will be solute. So steel, if you take example steel, so the carbon atoms that are induced into steel occupies the interstitial space. Occupies the interstitial space, that is called as interstitial solid solution. So these are all the carbon atoms, so which are occupying the interstitial space. So these are all the it is iron atoms. So iron atoms are more, that is why it's called as solvent, whereas the carbon atoms are less, that is why it's called as solute. So this is about interstitial solid solution. Two types, that is substitution solid solution, and second one is interstitial solid solution. So once we know about solution, what is solid solution, then types of solid solution. Next, very important one more topic is what are the factors that affect solid solubility. So alloy, if you want to form an alloy, one metal, atoms of one metal should combine in other. So if that is the case, what are the factors that affect the solubility of one in another? That is called as factors affecting solid solubility. So this is also called as Hume-Rotary rule. So Hume-Rotary was the person who worked on this concept, and he has come out with certain rule. So rule are nothing but the factors that affect solid solubility in one another. That is called as factors affecting solid solubility. Now here, coming to the factors, so we have got four factors. So first one is crystal structure, second one is relative size factor, third one is chemical affinity, and fourth one is relative valency factor. Now these are the four factors that affect solubility of one in other. Solubility of one in another. So first one is crystal structure. Now we have started with the basic concept in the first model where we have studied different crystal structure like simple cubic, body centered, face centered, external closed packed structure. Now this is the first factors that affect solubility of one in another. So if both the metals are of same crystal structure, so then solubility of one in another will be, that is more in it is higher percentage. So both, if you take two metals, metal A and metal B, so both metal A and B have the same crystal structure. So example, so that is body centered, BCC. So metal A has got BCC structure, metal B has got, that is BCC structure. So when they combine with each other, solubility of one combining in another will be more. That is first, relative, that is crystal structure. Now on the other hand, if it is different, then solubility of one in another will be very less. Solubility of one in another will be very less. That is the first factor, that is crystal structure. Then second one is relative size factor. So relative size factor is nothing but size of atoms or molecules. So structure is made up of atoms. Whatever may be the type of structure, it is made up of atoms. Every atom will have its own size. That is called as relative size. Now relative size factor is once again one more factor that affects solid solubility. Now if the size is smaller, so we have discussed interstitial solid solution where the atoms should occupy the interstitial space. So if that is the case, size of the interstitial atom should be less. Example, what we have seen, that carbon diffusing into iron. Carbon atoms size will be less than iron. So relative size factor. Now if both are same size, so then the solubility of one in another will be less. If it is less, then solubility of one in another will be more. Relative size factor. What is relative? So relative means combining, looking at both the atoms. If it is an alloy of 2 system, then 2 atoms. If it is alloy 3 system, 3 atoms. Here one factor what he has given is that if the size variation is there, what happens? So if it is same, okay. If size variation is different. So he has conducted a study and he says that if the size variation is between 8 to 15%, then alloy system is minimum. So variation, if it is between 8 to 15%, so combining, forming an alloy, it will be minimum. That is alloy of less combination we can get. On the other hand, if it is 15%, greater than 15%, so it is almost limited, we cannot form an alloy. So very good example is once again here copper and nickel for this relative size factor. Then third one is chemical affinity. So chemical affinity. So affinity is nothing but attraction. So where one atom should be getting attracted to the other. Chemical affinity. So chemically, if they attract each other, so then that is solubility of one in other will be very easy. If chemical affinity is less, so then it will be difficult. Affinity is nothing but attraction. So attraction. Now this chemical affinity. So if the chemical affinity is more, so then the solubility of one atom in another will be more. Solubility of one in another will be more. Now how we can check this chemical affinity? So periodic table, what we studied in basic chemistry. Periodic table where the metals are arranged in a systematic way, that is in a periodic table. Now if you look at the periodic table, so if the atoms are far away from each other, so then we can say that metals will have better chemical affinity. So we have to look that periodic table. Based on that, we have to choose the metal to form an alloy. That is the third factor, that is chemical affinity. Then fourth one and the last one is relative valency factor. So relative valency factor. Now here metal with high valency dissolve small amount of lower valency atom. On the other hand, metal with less valency have good solubility. Now two metals A and B. So metal A will have one valency, whereas metal B will have other valency. So valency is nothing but combining a factor which is expressed in terms of hydrogen atoms. So one atom, atoms of one metal combining in other. So it is expressed in terms of hydrogen atoms. That is called as valency. Now metal with higher valency dissolves small amount of lower valency atom. So if take metal with A metal which has got high valency, so then metal B has got low valency. Metal A will have high valency with dissolve only small amount of lower valency metal. So high, low, so only it will dissolve only small amount. On the other hand, if metal with less valency, so if it has got less valency, so then solubility of one in another will be higher. Solubility of one in another will be higher. So these are the four factors that affect solubility of one in another. It is also called as Hume-Rotary rule. Hello students. So today in this session, we will be discussing with one more concept that is about alloy. So what is an alloy? Importance of alloy, types of alloys, and concept of formation of alloys. So these are the topics I will be discussing today. What is an alloy? Concept of formation of alloy, types of alloys. Now coming to the first thing, definition. What is an alloy? So alloy is a combination of two or more metals. Alloy is a combination of two or more metals. Why we should have an alloy? The next question is. So when you have got so many metals that is available, so why we should have an alloy? Now if we take certain metals, every metal will have its own properties. Every metal will have its own properties. Requirement will be different. Suppose if I take example certain metals which have got strength. So if that metal has to be used in manufacture of a component that is exposed to atmosphere, or that will be in contact with water, so it gets easily corroded. It has got strength, it has got high strength, but it does not have corrosion property. So in such cases, so in order to improve certain properties, we should go for an alloy. We should go for an alloy. That is where this alloy metal comes into picture. So it is a combination of two or more metal. It can be combination of two metals, or it can be combination of even three metals. Example, very simple example if I can give is copper and nickel, or gold and this silver. So they are added in very less percentage, so that it gives the required properties. That is what the importance of alloy. It is a combination of two or more metals. So that's what the definition says. It is an alloy is a combination of two or more metals. Example, brass is an alloy of copper and tin. Now copper as a individually it has got certain properties. Tin as individual material, it has got certain properties. So when I combine these two together, when I combine copper and tin, so I get a new set of properties. And I get a new set of metal, that is what? Bronze. So bronze is not a metal that is readily available. Bronze is not the metal that is readily available. It is a metal that is got from combining copper and that is tin. So copper is readily available, tin is readily available. Now copper, it has got more hardness. It is harder than steel, but if I want to increase in hardness, I want more hardness, so then I can go for bronze. So bronze, copper plus tin added to copper, it increases its hardness. So bronze is more harder than copper. That is where the concept of alloy comes into picture. So like that, we can have three metal alloys also. We can have three metal alloys where we can combine three different metals. So we can combine three different metals and I can get a new metal with new set of properties or change in properties. That is called an alloy. Now, this alloy can be, as I told, it can be a two metal. So then it is called as binary alloy. If it is a two metal alloy, it is called as a binary alloy. If it is a three metal, it is called as a ternary alloy. Similarly, if it is a four metal. So metal here, component is nothing but metals. So four components, three components or two components. So if it is two components, it is binary alloy, called as binary alloy. If it is three component, then it is called as ternary alloy. If it is four component, it is called as quaternary alloy. So not just two metals, it can be three metals or it can be even four metals. So that is what alloy and how we can have different types of alloys. Then coming to the next topic. So once we know what is alloy, importance of alloy, and it is types based on either two metal or two component, three or four components. Next is formation of alloy. So formation of alloy is nothing but how an alloy metal is formed. Formation is nothing but how an alloy metal is formed. Now if you take an alloy of example, same this bronze. So copper and tin. So both copper and tin are heated, both are heated. So copper has got different heating temperature, melting temperature, then whereas tin has got different melting temperature. When both are heated and they are mixed together in molten state, so after solidification, so we get the new metal, that is bronze. That is concept of formation, that is in molten state, it is combined in molten states, where both the metals are heated. So if it is two metal, if it is three metal, all the three metals are heated. Every metal will have its own melting temperature. So once it is heated, then they are combined together. So then when solidification takes place, we get a new metal. So solidification, as it was discussed in the previous session, so where metals combines together, it changes from one form to another form. Changing from one phase to another phase, that is solidification. So from liquid phase to it gets changed into solid phase. So that is one concept how this alloy is formed, that is in molten state. We call this as the concept where that is an alloy metal is formed in molten state. So one more way how we can get an alloy is in powder form. So metals can be in powder form, that is initially it will be in solid form. So in powder form we can mix together in powder form and then heat it to a certain temperature, so where they combine together giving a new metal, that is once again an alloy metal. So two ways the formation of an alloy can take place. So one in molten state, second one is in powdered form. Second one is in powder form. So powder form we mix together. So then applying pressure and heating slightly to a lower temperature, applying pressure. So in powder, that is in solid state. Powder means it is in solid state. In solid state, they combine together. So when they combine together and pressed and applying the external pressure, so we get a new metal, that is an alloy metal. So that is the concept of formation of alloys. So once we know what is an alloy, types of alloy, formation of alloy. So one more classification of alloys is based on the application for which it is used. So we can have any type of alloy, we can combine any metal, and we can form an alloy. So based on the application or based on the properties, so we can have 5 different types of alloys. We can have 5 different types of alloys. The first one is bearing alloys. So bearing alloys. Now if you take any 2 components which are in sliding contact, so one slides over the other. So example shaft. So shaft sliding over other. So there will be contact with each other. So due to which, so that is the metal gets wear out very quickly. So to avoid that, we can have an alloy. So basically bearings. So bearing is one where bearing will be in contact with the shaft. So as the shaft rotates, bearing also rotates. So there will be contact between each other. Due to which, so it should have better wear resistance property. Then only its life can be increased. So that applications where there is friction arises, where there is contact between 2 parts. So in such cases, the alloys that are formed are called as bearing alloys. So where there is contact between 2 parts of different material. So when there is contact, so rubbing action takes place, and due to which wear and tear will be more. To avoid that, we can increase that wear and tear property. So that particular type of alloy is called as bearing alloy. Example, brass and bronze. So most of the cases the bearings are manufactured either by brass or bronze. That is one type of alloy. Then second one is corrosion resistant alloys. So if you take a metal when it is exposed to atmosphere conditions, so it gets corroded. So it is very simple thing, and everyone have been known about that, corrosion. So it gets rusted. So corrosion is nothing but getting rusted. So if you take iron piece, if it is kept in open atmosphere, so after a certain period of time it gets rusted. That rusting is nothing but corrosion, because atmospheric air combines with iron, so exposed to atmosphere, so it reacts with iron and it gets rusted. So we have to avoid that corrosion. So the alloys made for this purpose are called as corrosion resistance alloys. So corrosion, resisting the corrosion. So example, steel and aluminium. So steel, if you take a piece of steel and iron, keep it in open atmosphere for the same period of time, iron gets rusted, steel will not, because it has got corrosion resistant property. So that is once again a second type of alloy where it is used to increase the corrosion resistance property. Then third one is super austenitic stainless steel alloy. Now steel by itself has got better corrosion resistance property. Now in order to increase the strength along with corrosion resistance. So steel already has got corrosion resistant property. I want to increase the strength on the other end. Increasing the strength and corrosion resistance property. So we can have one more set of alloy, that is what called as super austenitic stainless steel. So here steel is heated to up to this austenitic temperature. So what is austenitic temperature, that will be discussed in other sessions where we will be discussing about phase diagram. There we come across this austenitic temperature. So that is the third one, super austenitic stainless steel alloy. Then fourth one is high strength corrosion resistant alloy. So we have already got corrosion resistance alloy. So increasing that. So many applications, the material should be highly corrosion resistant. So in such cases, we form alloys such which will have high strength corrosion resistant alloy. Example, that is titanium mixed with aluminum, titanium mixed with niobium. So where along with corrosion resistance, it increases the strength. That is one more type of alloy which can be formed. Then last one is steel alloys. Now steel, we have seen that different type of steels can exist. So like alloy steel, stainless steel, tool steel. So different type of steel can exist. Now each steel will have different property. So steel is nothing but iron. Iron to iron I can add sulfur, I can add molybdenum, I can add sulfur. So like that I can add chromium. So what is the metal that is added to iron? So we get different type of steels. That is the next type of alloy, that is steel alloys. So we can have tool steel. It is used only for applications of manufacturing of tools. High speed steel we can have. Then normal steel we can have. Stainless steel. So utensils are made up of stainless steel. So what is the metal that is added? To iron? So based on that we can get different types of steel alloys. So these are the different types of alloys that can be formed based on the applications or based on the properties. Bearing alloys, corrosion resistant alloys, super austenitic stainless steel alloy, high strength corrosion resistant alloy, and steel alloys. So this is about the concept of alloy. So types of alloys, formation of alloys, and once again alloys based on the application or properties. What are the different types of alloys we can have.